In this video, we are going to build a chatbot which can talk with your private documents, so you do not have to share your documents online with any platform like OpenAI. Also, this will be completely free and it will work offline because we are going to use free open source models for LLM as well as embedding. Apart from this, you do not need a GPU, it will work fine on your CPU as well. So, let's begin. Let's discuss the flow of the chatbot. So, first we have a PDF. We'll extract the text out of the PDF by using PyPDF library. Then we'll convert this text into smaller chunks because there is a limit on the context length of the LLM. Then we'll convert all these chunks into embeddings by using open source sentence transformer embedding model. Earlier we have used OpenAI model which costed us money, but this is an open source model, so it is completely free. Next, we'll store all the embeddings into a Chroma database. And once user asks the question, we'll convert this question also into an embedding by using the same sentence transformer model. After we get the question embedding, we'll find the similar text chunks which is similar to this question embedding. And these similar text chunks will pass into an LLM. This is like the context for the LLM to give us the answer. And then this LLM will give us the answer. And we can show this answer to the user. So here we are going to use open source LLM model as well, which is also completely free, which is GPT for all type of model. So this is the complete flow of the chatbot. Let's begin coding. So while building this chatbot, I came across this GitHub repository. The name is Private GPT, and this is absolutely amazing. So this will be the base of our code today, and I have changed some things in this code. I have simplified it. I was getting an error while parsing the PDF document, so I changed some libraries here. So we'll discuss the code one by one, and I'll just delete this first because I have created the embeddings already. So I'll just remove this. Okay, so first we will go to ingest.py. So here is the ingest.py document, and here from langchain.document loaders, we just want PyPDF loader. So earlier this repository was using PyMU PDF loader, which was throwing an error for me. So I have changed it to PyPDF loader. So I'll give you the link of both the GitHub, like my GitHub as well as private GPT GitHub link in the description. So first we'll import all the document loaders, and then we'll use LangChain to split the documents. We'll store everything into a Chroma database. So we are importing Chroma as a vector store. And then we need LangChain embeddings. And here we are using Hugging Face embeddings because we are importing sentence transformer model from Hugging Face embedding. And then we have langchain.docstore.document, and this is the document. So let's just see. So first we are importing, if not load, we are importing the environment variables. So here we have stored all the environment variables here. So persist directory. So when we create the embeddings of our text chunks, we want to store it in a database DB folder. Model type here is GPT for all, and model path is models, and this is the model name. And this is a open source model. So here in the models folder, I have downloaded this model, and I will give you the link as well of this model. You can download it. So here is the link in this repository of the GitHub. You can download it from there as well. So I have created this model path environment variable, and this is the path of the model. Again, the model name, this model name is of embedding model name, and we are using this model. And the context length is 1000, and model batch is 8. So this 8 is basically like how many tokens will go to LLM at once. And this is the target source chunks. So this will be the number of chunks we are going to pass into the LLM. Okay, so .env file is done. Now we can go back to ingest.py. Here first we'll import the Chroma settings from constants file. So here we have on the left, if you can see, constants.py. If we open it, so here are some settings, and this is define the folder for storing the database. And we have already defined this in our environment variable. So here, as we can see, persist directory equal to DB. So DB will be the folder name in which our embeddings will get saved. And also here is some settings for Chroma. So let's just go back to our ingest.py file again. Now here we are loading all the environment variables. So this is the persist directory, source documents, embedding model. So source document is a folder name. Here this is the source documents, and everything which is inside, like all the PDFs, all the CSVs, everything will get converted into an embedding, and it will take all these documents from this folder. So this is the name of that folder. This is the embedding model name, chunk size, and chunk overlap. So we have chunk size and chunk overlap. Chunk size is basically how many character length we want as a chunk, and this is the overlap of it. If you want the detail of it, you can watch my previous video. Okay, so next we have a loader mapping. So here we just focus on PDF right now because we have a PDF. And here earlier .pdf file was getting loaded by using this library, and this library was giving me an error. So I have changed it to PyPDF loader, and this is working perfectly fine. So I have imported this from like private GPT GitHub link, and it was throwing an error. So I have changed it to PyPDF loader, and it is working perfectly fine. Now we have two functions, load single document and load documents. So if you have a single document, how will you load it? So first it will check if this extension, like whatever the extension .pdf, .csv, it is present in the loader mapping or not. So this is the dictionary. It will check if it is present, and if it is present, it will take the respective loader, in this case PyPDF, and by using that it will load the document. And if there is an error, if there is some other file type which is not supported, it will throw an error, unsupported file extension. And if there are more than one documents, this function will come into play and it will load all the documents. Once we have loaded all the documents, we'll process it by using this function, load documents and split in chunks. So here it will load and split everything into a chunk. Next, we have one more function, does vector store exist? So it will check if already some vector store exists or not, if already DB is present or not. So this will check that, and if it is not present, it will create it. Otherwise, if it is present, it will append in it. So this is our main function. So first we'll create the embedding by using our Hugging Face model, which is sentence transformer model. Then we'll initiate Chroma client. After that, we'll check if the vector store already exists or not. If it already exists, it will update and store locally. If it does not exist, it will create a vector store and then store all the embeddings inside that vector store. So this is that function and it will run. So what we'll do, we'll just run it here in the terminal python ingest.py. If we run this, as you can see, there is no DB folder here and it will get created just now. So this is done, ingestion complete. You can now run private gpt.py to query your documents. So as we can see here in the left hand side, there is a new folder called DB. And in this DB folder, these are the two new files. So these are nothing but just the embeddings of this document. Now we need to question this document. So we'll go to private gpt.py file here. We'll open it. First, we'll load all the environment variables. Now we need embedding model again because we want to convert the question of the user into an embedding. Then we'll use persist directory. Again, model path, model type. We have already stored this in our environment variable file. We'll import the constant like chroma settings from this file, which we did earlier as well. And this is the main function. So now this parse argument function, I'll explain it later what it does. Let's go to embedding. So here we are using Hugging Face embedding, the same thing which we did earlier. We'll initiate the Chroma client first, then we'll initiate the database, and then by using asRetriever method, we'll find out the similar chunks to our query, to the question of the user. And after this is done, this will come into this retriever. Now here is the model type. So there can be multiple LLMs, like multiple type of LLM open source model. So here we are supporting only two Llama models, Llama CPP and GPT for all. And our open source model, this is a GPT for all type of model. So this is for that. If the type of the model matches these two, it will initiate the LLM like this. Otherwise, it will throw an error and it will show the model type is not supported. Once our LLM get initiated, now we'll use QA from chain type, retrieval QA. And by using from chain type, we are passing the LLM which we have already initiated. In this case, it is GPT for all. Next, chain type is stuff. So next we have retriever. Retriever is nothing but similar text chunks. Next, we have a return source documents. So we will show the source documents as well after the answer, unless we have explicitly told the model not to show it. So this is for that. I'll explain it later. Now we'll start the infinite loop here, while true. And if the query is equal to exit, it will break the loop. And if there is nothing in the query, it will continue the loop. Now we'll use this QA, which we have initialized earlier, and we'll pass the query into this. So what this will do, this will convert this query into the embedding, then we'll get the similar text chunks, and then it will get passed as a context into the LLM, and then LLM will give us the answer. And we'll get the answer here. We'll check the end time as well. We will show the user answer in the print here. And all these source documents will be shown as well. and this is the function parse arguments. So if while running the private GPT file, if we run the flag hide source or -s, it will not show us the source documents. Similarly, if we want to mute this stream, if we do not want to show like each word getting generated by the LLM, we can mute the stream and it will directly give us the like the complete answer. So I will just demonstrate it here. So we'll go and we'll type Python private GPT and we want the source documents. So we will not pass hide source flag here and we'll run it. So now it is running. Okay, so it will take a little bit of time. Now we can ask the question. So first question. So this document is about Transform Your Habits by James Clear. So first we'll ask how to build strong habits. And as this is working like completely locally, this might take a little bit of time. So I'll skip it. Okay, so it gave us the answer here, how to build strong habits. Building strong habits requires consistency, persistence, and self discipline. And here are the source documents as well. So now we can ask one more question. So it got interrupted. I'll run this again. And now ask, like, what are the steps of building a new habit? So this will be our next question. What are the steps of building a new habit? Okay, so it took a little bit of time because we are running everything locally and these LLMs are very large, so it requires a lot of RAM. So let's just see the answer here. What are the steps of building a new habit? And the answer is the 3 R's of habit change: reminder, routine, and reward. So this is absolutely correct because I have read the document earlier. And here are the source documents as well. So in this way, you can build a chatbot which can talk with your private PDFs completely free and offline as well. The only thing is it will take little bit of time because we are using open source model. If you want to make a chatbot which can quickly respond to your queries, then we need to use OpenAI LLMs. And I have made a video about that as well. You can check this out. Thank you so much.